Welcome, friends. In my series of lectures on radar engineering, today we are going to see about the block diagram of radar system. So, figure below shows the block diagram or representation of a radar. Now, basically, this radar block diagram is divided into two sections. First one is transmission section, other one is a receiver section. Transmission section consists of waveform generator, power amplifier, pulse modulator, duplexer, and the transmitting antenna. Receiving section consists of receiving antenna, duplexer, low noise RF amplifier, mixer, IF amplifier, second detector, video amplifier, threshold decision, and a display. So one by one we will see all these blocks. So we know that the radar system has a transmitting and receiving sections, and both the sections perform their respective operations. So let us now discuss how this radar operates. First one is the transmitter section. The transmitter section is composed of the following units. First one is a waveform generator. This waveform generator, usually it is a magnetron, generates a radar signal at a low power which can be transmitted into the space. So this is the block diagram of a transmitter section that we already seen. It consists of a waveform generator which generates a low power signal, and it generally consists of a magnetron, then the power amplifier, pulse modulator, duplexer, and the antenna. Now this transmitter, the signal generated by the waveform generator is fed to the transmitter. The transmitter section can be the magnetron, or it can be a traveling wave tube or a transistor amplifier. In case of a pulse radar, the magnetrons are widely used as a transmitter, but whenever there exists a need for a high average power, then amplifiers are used. Then pulse modulator. A pulse modulator is used to build a synchronization between the waveform generator and transmitter. The pulse modulator causes a turning on and off of the power amplifier according to the input pulses generated by the waveform generator. Now duplexer. Duplexer is basically used form of isolation between the transmitter and receiver. It is a two-way switch which forms the isolation between the transmitter and receiver section. Duplexer allows the use of single antenna for both transmission and the reception purposes. However, both the sections operate at a different power level. Therefore, duplexer is used to isolate these two sections. Thus, the signal from the transmitter is provided to the antenna through the duplexer, and as the duplexer short circuits the input of the receiver section. So when the transmitter is working, the duplexer will short circuit the input section, receiver section, and when the receiver is working, duplexer will short circuit the transmitter section. So it is a switch which allows only at a time connection of an antenna to the transmitter or to the receiver. So also a re-radiated signal received by the common antenna is fed through the duplexer to the receiver. Now this completes the transmitter description. Now we will go to the receiver section. So the receiver section consists of following components like low noise RF amplifier, mixer, IF amplifier, second detector, video amplifier, threshold detection, and display. So how they are working one by one we will see all these blocks. So first of all, a low noise amplifier. We know that when the signal is radiated from or re-radiated from the target, it has to travel in a free space. So large amount of noise is already there in the signal, received signal. So, and again that signal amplitude is very small. So we have to enhance the amplitude of this signal. So here we have to use a amplifier. But similarly, when we are amplifying the signal many times, we have to control the noise of the device. So here the first section which is used, that is a low noise RF amplifier. The receiver must be super heterodyne receiver, and this unit acts as the input stage for the receiver section. The RF amplifier generates an RF pulse which is proportional to the echo of the transmitted signal. The next is mixer and the local oscillator. The RF pulse received from the low noise RF amplifier is converted into the IF pulse. Usually, the RF amplifier acts at the input stage of the receiver section, but sometimes the mixer acts as the input stage by eliminating the RF amplifier. But this leads to the less sensitive receiving section due to the high noise figure of the mixer. So, this mixer will convert the RF frequency to the IF frequency. We are scaling down the frequency so that the operation will be simple and less costly. Now next comes in a picture is the IF amplifier. The IF pulse generated by the mixer circuit is amplified by the IF amplifier. It acts as a match filter and increases the signal to noise ratio of the received signal. Also, it enhances the echo detecting ability of the receiver by reducing the effect of unwanted signals. The receiver's bandwidth is associated with the bandwidth of the IF stage. Then, second detector or a demodulator. This unit is nothing but a crystal diode that performs the demodulation of the signal by separating the transmitted signal from the carrier. The next comes in a picture, that is a video amplifier. This unit amplifies the received signal to a level that can be displayed on the screen. The next one is threshold detection. This is very important section. So this unit makes the decision about the existence of a target in a space. Here some threshold levels are set, and if your received signal goes above that threshold level, you can say like that the target is surely present in that signal. Target information is present. If the signal is below the threshold limit, then we are considering that there is no target present or only noise is present. So basically it has some threshold limit to set, which is compared with the magnitude of the received signal. If threshold value is surpassed by the output signal, then this shows that presence of the target. Otherwise, it is assumed that only the noise component is present in the space or in the received signal. Then next is the display. The display unit shows the final output of the receiver section. Generally, PPI, that is plane position indication, is typically used as a radar display unit. It presents the range and the location of an object by mapping it in the polar coordinates. PPI is implemented with the CRT. The output signal modulates the electron beam of the cathode ray tube in order to permit the electron beam to sweep from center in the outward direction of the tube. And this sweep shows the rotation and in synchronization with the pointing of the radar of the antenna. So this completes the description of the radar block diagram.